This is a video on using Simpson's rule to approximate an integral. The question states, use Simpson's rule with n equals 4 to approximate the integral from 1 to 9 of 1 over x dx. So let's recall Simpson's rule. What it says is that the approximation is equal to b minus a divided by 3n times f of x naught plus 4 times f of x1 plus 2 times f of x2 plus 4 times f of x3, and then it oscillates from 2 to 4, 2 to 4, 2 to 4, until the last two terms are 4 times f of xn minus 1 plus 1, or just f of x sub n. So we have that a is equal to 1 because that's the lower limit. We also have that b is equal to 9 because that's the upper limit. When we're looking at x0, x1, x2, etc., we always start at 1, or we start at our a, and then we move along delta x to get to the next one. And we calculate delta x by taking b minus a over n, just like when we did left and right rectangles. So in particular, delta x is 9 minus 1 divided by 4, which is equal to 2. So that way our x's will start at 1, and then jump by 2 to 3, and then go to 5, 7, and 9. So let's plug everything into Simpson's formula. And what it says is we have b minus a, that's 9 minus 1, over 3 times 4. And then we have f of x naught. F is the 1 over function, and we started with a 1. And then 4 times f of x1, again 1 over, and we're at 3 now. And then 2 times f of x2, so 1 over 5. And then 4 times 1 over 7. And then finally 1 over 9. So I used a calculator, and I approximated this to be about 2.277. And that's a Simpson's rule approximation with n equals 4 of the integral from 1 to 5 of 1 over x dx. And just a note, if you use a calculator, you'll find out that the actual integral up to 10 decimal places is 2.197224577, which is pretty close to our estimated one, 2.2 at least. We got 1 decimal place of accuracy. And I'm done with the problem.